Hello and welcome. I like to present a fresh examination of the Figuera apparatus, commonly known as the generator. My investigation centers on the behavior of the secondary coil when subjected to excitation from primary coils with concordant phase and polarity. While the repulsion of magnetic waves with identical polarity is expected, the conduction of electrical waves remains a topic of considerable interest. It is possible that under these circumstances, scalar waves could be formed, enabling tuning into the scalar field, which is commonly understood to propagate at 1.4 to 1.6 times the speed of light, indicating a new, significantly higher frequency for resonance. This phenomenon is characterized by the electrical fields of the primary coil, which exhibit a far lower electrical potential than the secondary electrical potential. The test rig comprises a portion of the original design for the purpose of preliminary investigation. There are 6 primary coils and 3 secondary coils, positioned centrally to each pair of primary coils. All coils are connected in series. The primary coils are connected in series for each string, but both strings are in parallel to enable simultaneous polarity excitation on both sides of the primary coils. A capacitor is added to the primary and secondary coils in parallel to the output, facilitating reduced resonant frequency and higher power circulation. Ferrite is utilized as the core material rather than steel to more readily demonstrate the behavior on the oscilloscope. The original design was constructed with soft steel cores, and power switching was accomplished with a rotational resistive wire for both sides of the primary coil independently, such that each side experienced differing resistance to the power source in rapidly changing successions, without interrupting the signal to avoid back EMF. My initial demonstration aims to showcase the influence of similarly polarized magnetic fields on a core material.
Here on a table I have 2 magnets with north and south pole. In the middle I have the ferrite rod I use for our coils, and I have a compass on top to measure the weak magnetic fields of the magnets. The compass will measure the electromagnetic, the magnetic field of the coil. And as you can see here, the ferrite does not get magnetized. So that is a benefit of ferrite materials, that it does not get magnetized. However, when we have the coils, that is the case. So we have 2 north poles facing at each other. Then depending on how strong which north pole is, it will go in this direction, indicates that as the strongest field, for example here at the moment. So if we take now the ferrite rod as it is in the coil, and let's say we are connecting they're fairly weak, these magnets. We connect it here and here, so this one is stronger than this one. But if I move around here, you can see where it goes, and this one is not that strong. So we have a little bit of an imbalance here, but it's, just bear in mind that our coils magnetize in the same energetic way. That means both magnetic poles will be identical from a strength point of view. But what happens here in this material? Because it's not that strong, so it propagates along that line, both of them, and in the center they repel. But if I go here, look at that, and then in the center it focuses in, because here the north pole, the polarity or the magnetic field lines move around back to the south, here as well from the north back to the south, from both sides back to the south, and because they're now extended here, they go from here out back to the south. So if this both fields would be stronger or as strong as possible, then they would tear apart the ferrite exactly here in the middle and they would split. However, it requires a really strong magnetic field to do that. Even with my neodymium magnets I have, I cannot achieve that. So after the table I have now connected all the primaries and the secondaries, so we have equal distances to the secondary. We measure on the secondary, we measure current and voltage. We have the circulating power for our values. We take then the power for RMS out as well, and we measure also the voltage here on the primary coils. And from the power supply, we're taking off how much power we consume in terms of watt. So my first frequency is 3200 kilohertz, and I energize now. We can see that we have here yellow is for the primary, that means it here is on channel 1, we say 144 volt RMS, and we have half the voltage only on the secondary. Current is currently here 85 milliampere. I measure on my current board 55 milliampere, but I can take that out. You can see if the value corresponds to the power supply. If I get it up here, I have 97 or 90, between 90 and 97. It's a bit higher than as it is indicated from the power supply, DC power supply of the power bench. If I go up to the next frequency, which would be then the resonant frequency for this coil arrangement, let's do that now. We go around here, 5000 goes to so the highest value is going up. Let me zoom that back in. So it's 7,200, I think, and as you can see here, we have on channel 1 we have 270 volt RMS, and we have on channel 2, that's the secondary, 132 volt. I consume on a power supply 200 milliampere. I measure here on a secondary, but only 73 milliampere. So if I take that over now again to the primary coil, I measure 163 milliampere, is a little bit shy to what we have on the DC power supply. I'll put it back. So now the question is, if that's our resonance frequency, and we assume, or let's say we think we might be able to tune into the scalar wave frequency, bear in mind we have no wire connected, so there is technically no physical link except the magnetic field from the coils. Can I tune under these circumstances to the scalar field? Let's find out. I'll go up in the frequency. And it comes up here, 9,589. So what we see now is we see on a primary only 58 volt RMS. I see twice as much on a secondary. I see 170 milliampere on the current, and I have only 45 milliampere from the DC power supply. Now let's see how that pans out. I take the current probe and connect it here to the primary, and I measure 43.44 milliampere. So that is confirmed. It's identical what we have on the DC power supply. I put it back here, and please bear in mind we have no magnetic field radiating out. We have core materials. There is no influence. If I keep it like that, you see it measures here 1.5, it's 1.5 milliampere is currently the default current measurement here without ground connection. I did it on purpose, not to have any kind of current coming in there. So, but here I measure 160 milliamperes. That means we have over 10 watt circulating power in the system. So that confirms we can tune under this circumstance in the scalar field. So there are options now available. We can use this kind of field. So the way I was thinking about, you can't tap into this energy, take it out, but we can use this arrangement as a radio transmitter where we have very, very little power on our input side to produce it on a primary coil, and on the output side we have a tremendous amount of more power for radiating radio frequency. So this concludes my video I have produced for you today in a short term. If you have questions, let me know, and I will see if I can find a couple of more interesting facts about this generator from Figuera. Thank you.